Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Maximizing Performance and Minimizing Distortion, Advances in Papa Reduction for Wireless Networks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPex Research and Innovation Services. Today I'm here to present you one of the applications that we have designed in the domain of wireless communication, where we are reducing the PAPR issues of the wireless network. So in order to achieve that, we have designed a system where a UFMC model has been introduced. So let's move to the video. Before starting the video, let's talk about that what we will cover into this video. In this video, initially we will talk about in which application areas the developed system will be helpful and which categories can be covered under that. Then whatever the code we have designed, how to execute it, which files you have to run, whatever software requirements will be shared. Then we will give that what exactly the current systems are doing in the same domain and what is the proposed system additionally doing. And finally, the overall results and the comparisons will be analyzed. So let's talk about the application area. As wireless communication network is popular in many of the areas everywhere currently, even in the with the IoT systems also the wireless communication is there. So it is applicable in many of the areas such as smart agriculture for the buildings, intelligent transportation, medicines, biomedical application, industrial based applications, for the aerospace, for the computer systems, IoT, Wi-Fi or Bluetooth based communication. So many of the domains can be covered under the wireless communication. So one of the thing is like protocols for transferring the data from one form to another or one place to another. And second thing is like how the system is actually working, what exactly the signal we are receiving. What one is at the protocol level, another is at the data level. So the system that we have designed is on the data level, that whatever the data we are transferring, how we are transferring, and what is the impact at the receiver and on the data in order to identify the bit error rate and all that stuff. So the problem that we are highlighting here is PAPR. So it is a peak average power ratio. So peak average power ratio, which is generally in the OFDM based systems, which are basically the wireless communication module. So in this, if we will see what exactly the PAPR ratio is, you can see uh, when the data is transmitted here, if the data was under a limit, right? But when it is receiving at the transmitter before the reception, you can see the peaks of the data get increased, which is basically the regrowth. So that is basically the issue which raises the amplitude of the signal and impact the actual signal. So in order to avoid that, many of the technologies has been implemented. Even in the some of the people are understanding it like it was only at the initial stage of the wireless, but currently even in the 5G technologies also, PAPR is playing an important role. So to control this issue, there are certain technologies that working on. So one of them is that we have proposed. So let's see how the code is to be executed. The folder that we will give you is this, in which all the files has been placed. In order to run this code, you must have the MATLAB software with you. The MATLAB software that we are using is 2019, so you can use 2018 or the upper version in order to run this code, but make sure it should be a full version or the trial version. To run the code, you just need to go to the folder where the code is there and copy the path of the folder, and then go to the MATLAB and place it here and press enter. When you will press enter, all the files will be seen here. We have done the code in multiple scenarios where we have initially evaluated that what exactly the code is. One of the code is main OFDM, in which the normal OFDM system at different modulation schemes has been run to check the impact of the systems. Then it is done with the by changing the channel. So in the main OFDM, only AWGN channel is considered. In main 16QAM, relay fading channel has been introduced in the system to analysis the impact, and then the proposed signal is there, in which firstly the we are just developing the system for the OFDM with introducing the concept of UFMC. So UFMC is basically, so if we will talk about the UFMC, so you can see it is basically universal filtered multi-carrier modulation, a new modulation scheme which can assist in handling the issues having the filter banks for the multiple carriers. So we are showing that how OFDM based communication system or UFMC based communication systems are improving the PAPR issue, because UFMC is basically used in the many of the recent technologies including 4G, 5G and many other, but still it is under improvement. So at final stage what we have shown, because UFMC is already existing, so we are improving the UFMC. So that is in the proposed code where we are applying the PTS PAPR reduction technique with the UFMC, one of the thing. Second, we are adding the PAPR reducing technique PTS with the UFMC and filtration technique which is a Butterworth digital filter. So we are showing the results that how in order to improve the UFMC, if PTS PAPR reduction technique is clubbed, then what is the impact? And finally we are proposing the overall technique of UFMC plus PTS PAPR technique plus Butterworth digital filter in order to reduce the impact on the bit error rate and the PAPR reduction. So let's run the code. In order to run the code, firstly the main OFDM is to be run. So I'm running this. It will show you the results in the term of this is bit error rate. Here you can see by changing the modulation 2QM, 4QM, 16QM and 64QM what exactly the impact is. So as the modulation scheme is increasing, the bit error rate is also increasing. Then we are applying it with the relay fading channel and analyzing the results that what exactly we do have. So here you can see in the results section it is running for multiple iterations because we are running for the multiple QM schemes. So the results with us is this. Here you can see by introducing the concept of relay fading the error is higher because obviously the impact is there. So this is basically the QM using the UFMC, normal QM with the UFMC over the relay fading channel. So initial was the OFDM with the AWGN. This is UFMC with the relay fading, right? So next part is when we are comparing OFDM with the UFMC in a single one at 16 QM only. So in this you can see UFMC will give you the better results in the terms of the PAPR reduction in comparison to the OFDM, which is motivating the researchers to work in this domain. So this proves that UFMC is better than the OFDM. So finally we are improving the current current UFMC because even in the OFDM systems, when the different techniques has been implemented, the PAPR can be reduced to certain state. So this is without any additional technique applied to the UFMC, but still it is better than the OFDM. So in order to improve it more, we have proposed the recent technique in which initially only PTS technique is implemented along with the UFMC, and then a Butterworth digital filter concept has been introduced. So you can see whatever the results we will find, it will be on the screen shortly. So the modulation scheme that we have used is QM, and the Butterworth filter that we have applied on the signal to reduce the bit error rate and to maintain the quality of the signal at the receiver end. So the overall system is designed on the data level, not on the normal routing or other levels. So this is related to the communication phases. So you can see the results here. This is the result that we have achieved for the UFMC with PTS and Butterworth at 16 QM. This is the comparison when UFMC is applied with the PTS only and UFMC is combined with the PTS and the Butterworth. You can see the curve of the technique is providing less PAPR in comparison to the 16 QAM UFMC with the PTS. But what when it is compared with normal UFMC and OFDM, so you can see in both the scenarios, even both the cases with the UFMC PTS and proposed UFMC PTS and Butterworth are giving better results and reducing a PAPR up to an extent in comparison to normal OFDM and normal UFMC. So this is the overall work that we have done in the same scenario by analyzing the different cases and finally giving the proposed technique. So further modifications are still possible because here we are combining the UFMC with the PTS. Certain other advancements can also reduce the PAPR up to an extent more. So for those details, you can contact us directly and can get the details. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPax. We look forward to collaborating with you on your research journey.